Hello everybody, this is going to be a quick video on phasers. They are Java's implementation of a feature called from X10 called clocks. And so this not uncommon pattern right here where I have a sequential outer for loop and a parallel loop inside. Let's just look at IntelliJ and see how it works. So here's the program I was just talking about. Let me just run it real quick. And so you can see that I have tasks A, B, C, and D. So I created a join void fork loop here. With each one, I'm going to just print them out with their number. And outside of that, I have this sequential for loop that goes from 0, 1, 2, 3, up to 5. So it goes up to 4, or up to and including 4. And so you can see that I don't know exactly what order the parallel things are going to happen in. That's fine. But I know that all the zeros will complete before the ones complete, before the twos go, right? That makes sense because this join void fork loop launches a bunch of tasks, completes them before you move on. So each cycle does this sort of thing. And so back to the slides, right? So we had this program. You can see the computation graph over here. There's just this repeated set of fork loops where you start a bunch of tasks, you join them all, you throw those tasks away. You start a bunch of tasks here with the next iteration of this sequential loop. I do another whole new call to join void fork loop, which makes a whole new set of tasks, which gets joined, and I throw them away. And then I come right back around and I do it again, right? And so I just keep doing this over and over again. There's a lot of overhead in here between all this, creating a bunch of tasks, joining them, and destroying them, then coming back and destroying them again, as well as some memory concerns. Anybody who's interested about the memory concerns, there's a bonus situation there where the same tasks won't be on the same machine. And so basically what happened is X10, which was a programming language designed for parallel type things, came with a bunch of things, including this clocks concept where you could say next, which would serve as a barrier between phases. Java liked this so much that they added it straight into Java in a Phaser class. They changed some of the names a little bit, but what I really like about this is we have a citation policy in our class. I like that Doug Lee, when building this into Java, was like, hey, let's just give a shout out to X10. There's nothing wrong with that, no matter where you are. And so let's talk about how this plays out in with a phaser. Let's get the same behavior. We like this behavior. It's required for a lot of programs where each task within it, like you imagine a bunch of data, all the data can be processed in parallel, but I must iterate over it, or I have to do them in phases where the previous phase has to complete. So let's talk about this. Let's come over here, and I'm going to just edit this program a little bit. So I have this thing. We're going to build it. It's for phased. I'm just going to start by copying our program over here into it, and I'm going to modify it in what should, at least to many of you, seem like a crazy way. So I'm going to go like this. I'm going to take this outer sequential loop and this inner parallel loop, and I'm just going to flip them inside out. And so as you might imagine, I don't need the underscore I anymore because I'm going to put the sequential loop right inside. Let me get rid of that one, and I'm going to format this guy. And so as you might imagine, I can drop the underscore I because I dropped the final problem. And so if I do this, that's going to be my multiple forks loop again. Let me run this program right here, the basic phased one. You can see by flipping these two loops inside out, I have not preserved the same behavior. That makes sense. You can't flip normal parallel loops or normal loops inside out and expect them to always be the same. Certainly a parallel and a sequential loop being flipped outside, you wouldn't expect it to keep the same thing where all the zeros would happen at the same time. But if we use the X10's version of this thing, which has, or I built a X10 version of it, we're going to make a phase join fork loop. And so if I take this guy and create a task for each one of my tasks, A, B, C, and D, it will also pass you a phaser. Okay? Now, by itself, it's not going to do anything. So if I just run this program, the phased one, it's going to produce that same sort of nobody's really orchestrated with anyone else kind of behavior. But if I say phaser dot arrive and await advance, which is much like the next concept from X10, now all of a sudden I get back to exactly the same behavior I had before. So let's look at how this works. Again, you flip the loops inside out, and it passes you a phaser which enforces this. Everybody get together. Let's all synchronize. Again. And so I come back to this program, right? You can see that what this arrive and await advance is happening in this computation graph is instead of the old one, which said, oh, start a fork loop, join them all, like make them all complete, throw away all those tasks, come back, start a whole new join void fork loop, create a bunch of tasks, get them running on separate processors, join them, make them complete. Instead of all that overhead, what it does is it just puts in this node. You can think of it as, arrive and await advance is like make everybody join over and over again, right? Make them all join, do the next bit of work, make them all join, do the next bit of work, make them all join. And so we just launch the task once. We don't have to destroy them. We don't have to join them, destroy them, throw them away, create them again. We just keep them around, hanging out on their same processors, which has a little bit of memory improvement also. And we can just join over and over again. We sort of have these join edges in here in this arrive await advance. So again, somewhat counterintuitively, you can flip these two loops inside out, and within that sequential for loop, you can save arrive and await advance. How the code actually looks, not in a sort of pseudocode way, sort of the same thing. It doesn't look much different, right? Like I'm going to flip them inside out, use one of these phased join void fork loops, and just call this arrive and await advance, which will have me doing the same work. Everything can run in parallel with each other, just like before. I just have less overhead in this whole launching task, joining them, throwing them away, launching task, joining them, throwing them away. And so that's what you can do with phasers. We will be using them in this class, and I hope this video will help.